Today we're going to be talking about independent and dependent events. We're first going to be talking about independent, so that's our first blank. And you should know what independent means, but in case if you don't, it's when one event does not affect the other event. So it is basically fine all by itself. The probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So if one event does not depend on the other event, we can just multiply them. So example 1, we have a spinner and a number cube, which are used in a game. The spinner has an equal chance of landing on one of the 5 colors, red, orange, purple, yellow, or green. The faces of the cube are labeled 1 through 6. What is the probability of a player spinning green and then rolling a 3 or 4? Now this example is an independent event because whatever you spin, it doesn't matter, it won't affect what you're going to roll on the number cube. So for the first part we want to get green, and there's one green spot out of 1, 2, 3, 4, 5 options. And then when we roll our dice, we want a 3 or a 4. So that's 2 options out of a total 6. Multiply that together. 1 times 2 is 2. 5 times 6 is 30. And then we can reduce that by dividing both by 2. And we get 1 over 15. Okay, on the next page, number 2, a game requires players to roll 2 number cubes to move the game pieces. The faces of the cubes are labeled 1 through 6. What's the probability of rolling a 2 or 4 on the first number cube and then rolling a 5 on the second? This is an independent event because you have 2 separate number cubes. Well, even if you had 1, it doesn't really matter because after you roll a number cube once, you can get a 2 or a 4. Then when you roll it again, it doesn't matter what you got the first time, you can still get a 5 the second time. So 2 or 4 for the first event, so that's 2 options out of my total 6. And then the second number cube I want a 5, so that's 1 out of 6. Multiply that together. 2 times 1 is 2. 6 times 6 is 36. Divide both numbers by 2 and we get 1 over 18. And if you wanted to figure out what that is as a percent, do 1 divided by 18. That gives you the decimal. Move your decimal over 2 places. Number 3, a red number cube and a white number cube are rolled, so 2 separate cubes. The faces of both cubes are numbered from 1 through 6 again. What is the probability of rolling a 3 on the red and rolling a 3 or less on the white? So this is a lot like number 2, and so they are independent for the same reason. For the red cube, we want to get a 3, so that's 1 out of 6. For the white, we want to get 3 or less, so we want a 3, 2, or 1. That's 3 options out of 6. Multiply that together. 1 times 3 is 3. 6 times 6, 36. Divide both numbers by 3. We get 1 over 12 as our probability. Next we're going to be talking about dependent events. It is very, very similar. We are going to kind of combine what we just did with what we know about permutations. So a dependent event is kind of the opposite of an independent event. It's when events do affect each other. So we'll look at some examples like that. And to find the probability of a dependent event, you're still going to multiply. We're going to take the probability of the first event times the probability of the second event after the first event happened. So example 1, there are 4 red, 8 yellow, and 6 blue socks mixed up in a drawer. Once a sock is selected, it is not replaced. So that is the key phrase for figuring out that it's dependent. It is not replaced. If the socks were replaced, it would then become independent because it doesn't matter what you picked the first time since you're going to put it back. you still have the same options when you choose the second time. So since it is not replaced, that is why it is a dependent event. We are going to find the probability of reaching into the drawer without looking and choosing 2 blue socks. First thing we need to do is figure out the total number of socks we have. So our total would be 4 plus 8 plus 6, which would be 18. So for the first time we choose a sock, we have 6 blue socks, so 6 out of my total 18. The second time I want to choose a blue sock, I only have 5 blue socks left, so 5, and I only have 17 now in the drawer. So we had to subtract 1 from each number since we took out a blue and we took out a sock in general. Multiply that together. 6 times 5 is 30. 18 times 17 is 306. Divide both numbers by 6 and we're going to get 5 out of 51. Number 2 has a lot of different questions. I'm going to go ahead and scroll down so I can have them all on my page at once. It says there are 4 oranges, 7 bananas, 5 apples, and a fruit basket. So again, you have to figure out the total number of fruit, which in this case would be 16. 4 plus 7 plus 5 is 16. You select a piece of fruit at random, and then your friend selects a piece of fruit at random. Find the probability of each event. So the reason why this is dependent is because after you pick a piece of fruit, you're not going to put it back. You're going to eat it. So then whatever your friend has to pick, that's one less fruit she or he has to choose from. So for part A, we want the probability of getting 2 apples. Well, right now there are 5 apples out of my total 16. And then if your friend wants to choose fruit next, then there are now 4 out of 15. So we just subtract 1 from each number. So we get 20. Actually, I'm going to go ahead and cross reduce. I think that's a little easier. We can reduce that by 4. So we get 1 and 4. Reduce 5 and 15 by 5. So we get 1 times 1 is 1. 4 times 3 is 12. So my probability is 1 out of 12. Number 2, we want 2 bananas. So we start off with 7 bananas out of my total 16. When your friend chooses, there are 6 bananas to choose from with 15 fruit left. Again, we can cross-reduce a little bit. 6 and 16 can both be divided by 2. 6 divided by 2 would give me 3. 16 divided by 2 is 8. I can also reduce my 3 and 15, divide both by 3. So I get 7 times 1 is 7, and 8 times 5 is 40. So my probability is 7 over 40. Part C, we want an orange, then an apple. So when we first choose our orange, there are 4 oranges out of my total 16 pieces of fruit. When your friend chooses, since we chose an orange the first time, then we still have 5 apples to choose from. So 5 out of, now I only have 15 pieces of fruit. So that one was slightly different just because they were different pieces of fruit. We had 4 oranges out of a total 16, and then we had 5 apples out of now 15 pieces of fruit. We can cross-reduce a little bit. We can reduce 5 and 15, divide both by 5, get 1 and 3. 4 and 16, divide both by 4, get 1 and 4. 1 times 1 is 1. 4 times 3 is 12, so it's 1 out of 12. Part D, we want the probability of getting an apple, then a banana. So it's very similar to part C. When we chose an apple, we had 5 out of 16 options. Then a banana, there are 7 out of now 15 options. We can cross-reduce a little bit. 5 and 15, divide both by 5, get 1 and 3. So 1 times 7 is 7. 16 times 3 is 48. So our answer is 7 out of 48. The last one, we want 2 oranges. There were 4 oranges to choose from at the beginning, so 4 out of 16. Times, now that I chose 1 orange, I only have 3 left out of 15. I can reduce again, so 4 and 16, that turns into 1 and 4. 3 and 15 turns into 1 and 5. So we get 1 out of 20. So that is how you figure out the difference between independent and dependent events and how to find the probability for each.